Now let's look at the true or false quiz, also at the end of that chapter. So this is asking, determine whether the statement is true or false, and if it is true, explain why, and if it is false, explain why, or give an example that disproves the statement. Alright, so let's take a look at question 1 here. So if the limit as n approaches infinity of an equals to 0, then the summation an is convergent. In this one, it's obviously going to be false, because just because the limit is going to 0 does not mean it is convergent. We'll go over to the solution right here. So, solution, this is false. So recall from my earlier video, here it is. This is from the geometric series article/video. And this was the theorem given there. So if the series, the summation from n equals 1 to infinity of an is convergent, then the limit as n approaches infinity of an equals 0, but not necessarily the other way around. Just because this is convergent, so if this is convergent, then this limit has to go to 0. But if this is going to 0, does not mean it's convergent. So note 2, the converse of theorem 6 is not true in general. If limit as n approaches infinity of an equals 0, we cannot conclude that the summation an is convergent. Observe that for the harmonic series, which is a p series, summation from 1 over n, we have an equals to 1 over n approaches 0 as n approaches infinity, but we showed in example 7 that summation of 1 divided by n is divergent. It's also a p series, and it's a divergent p series. Yeah, and I just added a note here. So note also that the harmonic series, the summation from summation of 1 over n, is a divergent p series, and we could actually have a look at p series right here. And let's go back to it. And yeah, that's right over here. So this was part of question 3. What is a p series, and under what circumstances is it convergent? To recall here, so p series, the summation from n equals 1 to infinity of 1 over n to the power p is convergent if p is greater than 1, and divergent if p is less than or equal to 1. And in our case, the harmonic series is less than or equal to 1. And when it's it's equal to 1. So 1 over n goes to 0, the terms, but it's not convergent as per the p series. Let's continue further now. Alright, so let's just teleport back here. So yes, it is a p series, and yes, so this statement is false. So that harmonic series, the terms go to 0, but the summation of the terms don't. The summation of the terms don't converge to a single value. They go to infinity. So in other words, it's not a convergent series, so the statement is false.